So today I will show you how to control an LED with your Raspberry Pi 4, which is also work with Raspberry Pi 3 and as well as 2, and we are also going with Python 3. So controlling an LED is the first step you can take to discover how GPIOs work and what to do with them. So after this, you will be able to take other steps to build cool projects with your Pi. So first, we will do a little bit of setup and then dive into the Python 3 program, right? So see here, the first step is hardware setup. Then we can go for the programming part and then we run it and see the output, right? So before making connection or before powering up a Raspberry Pi, we have to make the hardware setup. So first of all, make sure your Raspberry Pi is powered off. So this is very important. Never plug or unplug any hardware component while your Pi is powered on. So you could damage it, for example, with an ESD. ESD is nothing but electrostatic discharge, or even completely destroy the CPU if you make a wrong pin connection. That's why, okay? So but don't worry too much either. If you are always extra careful and double check everything you do, nothing wrong will happen, okay? So what are the things we need for this connection? First one is a breadboard, and we need a Raspberry Pi with GPIO header, and then one LED. The color doesn't matter, you can choose whatever you want, and one resistor. It can be a 1k ohm or 2k ohm will be fine. Here I am going to use 1k ohm. This is just for LED, right? So we can go for 1k ohm. This is pretty much enough. And you have to have a set of male to female wire, okay? So before getting into the programming part, we can move to the hardware setup first. So here also I will provide the pin out diagram. It's very useful when we make connection, right? So let me tell you one thing. I'm going to take the pin number GPIO 17. We only need two things. One is ground, another one is the pin. Here I'm going to take GPIO 17, which is nothing but pin number 11. So let's forget about the pin number here. Let's only talk about the GPIO number, okay? So I'm going to take GPIO 17. So let's move to the hardware part. So here we are having Raspberry Pi 4, one LED and one 1k ohm resistor. So see, in this LED, so we are having two legs, right? So one is the short and another one is the long leg. So the short leg is negative and the long leg is positive. I am going to place it like this. And here I have 1k ohm resistor. So we have to place this 1k ohm resistor at the positive end of the LED. So I am going to connect it horizontally like this. And now let's make connection. So the negative leg of the LED has to be connected with ground, and the other end of the resistor, which we have already connected with the positive end, right? So the other end of the resistor has to be connected with the GPIO pin number 70. So in the pin chart itself, you can see the 9th pin number is ground. I mean from the left side, 5th pin, right? So I'm going to connect it to the 9th pin here. So 1, 2, 3, 4 and 5th pin. And after that 9, which is what 11, I mean GPIO 17, we have to connect it like this. So that's it. This is our connection. Okay. Now let's move to the programming part. So now that everything is correctly set up, we have already set up the hardware. Now we can go for software. So for that, let me connect the Raspberry Pi to my laptop. Okay, we have to wait for a few seconds. It has to be boot up, right? So in the Raspberry Pi itself, you can see the red LED has turned on, which means I powered up my Raspberry Pi, and you can see that green LED is blinking up, right? So it is booting up. So let us wait for a few seconds and then we can go for the VNC viewer and let's connect our Raspberry Pi, okay? Okay. We open VNC, this one. Okay, it is asking for my password. Here also we have to give password and I'm going to log in. Okay, So we need to open our Tony ID, right? So go to Raspberry Pi, programming, Tony. Okay. So let us write the program here. So let's write a minimal program. We are just going to simply power on and power off the LED. Okay. So for that, first what we need to do? We need to import module. Here I am going to import RPI dot GPIO as GPIO. Okay. So see, this particular line imports the RPI.GPIO module and rename it to GPIO for easier use in the code. So instead of using RPI.GPIO every single time, we can just give like GPIO. So this module allows Python code to interact with GPIO pins on a Raspberry Pi. Now we can import time. So this time module which provides various time related functions. So it's commonly used for introducing delays in code execution. Now let's mention our pin number, LED pin number. I'm going to give a variable name like LED pin which is equal to 17. So this line defines a variable LED pin and assigns it to the value 17. So this variable represents the GPIO pin number to which the LED is connected. So now the next thing which is I'm going to give like GPIO dot, I'm going to set the mode using GPIO dot set mode function. Instead I'm going to give like GPIO dot BCM. So this line set the GPIO numbering mode to BCM. BCM is nothing but Broadcom SoC channel numbering. So this mode refers to the numbering system of the GPIO pins on the Raspberry Pi's Broadcom SoC. Okay. So now let's move to the next line, which is I'm going to set like GPIO dot set up. So inside the parameter, inside as parameter, I want to pass LED pin as input. Sorry, not input, it is output, right? So GPIO dot, I'm going to set it to output. Okay. So this line configures the specified GPIO pin, which is nothing but LED pin, as an output pin. So it tells the Raspberry Pi that the pin will be used to do output, which means it's going to send data, in this case, to control the LED. Okay. So now another thing, GPIO dot output, inside I want to give like LED pin. I'm going to make it high using GPIO dot high. So in this line specified GPIO pin, the LED pin, to a high voltage level. So it means it's going to turning on the LED. So the GPIO dot high indicates setting the pin to a logic high. Here 3.3 volt. And I'm going to print a message like just on. Okay, just I'm going to print a message like on. Now I'm going to give a delay using time dot sleep. Here I'm going to give just 1 second. Okay, so now the same thing, we are going to make it low for another 1 second. So instead of this, we can copy this and we can paste it here. So instead of high, you can give like low, and instead of on, let me change this to off. And after all that, we can give like GPIO dot cleanup. Okay, so this line cleans up the GPIO resources used by the program. So it's a good practice to call this function at the end of the program to release the GPIO resources and reset the pin to the default state. I hope you remember this topic. We have already talked about this cleanup function in the previous classes, right? So these lines together control a single LED connected to the pin number GPIO 17 on the Raspberry Pi. It's going to turning it on for 1 second and then turning it off. So let me save this. Yes, let's give like sample.py. Okay. Yeah, we save this. Now let's run this. If I run this, see, on and off. So for 1 second it will be turn on and another 1 second it will be turn off. So this is our output. So now what we are going to do is that the same thing, but we are going to modify this program. We are going to make the LED blink. Now we just turn on and turn off. When it is turned on, it will print a message like on. When it is turned off, it print a message like off. So now we are going to make the LED blink. Let's improve the program by making LED blinking indefinitely. Okay. So for that, the same thing, we just need to modify a few lines. Okay. So we are going to put these lines. We don't have to print something like that in here. So let me take it off. What we need to do that, let me copy this and let me paste it here. So we are going to put these 4 lines of code into while true. Okay. So let me cut this, and if I hit enter here, you will know the indentation here. So we have to paste it here. Okay. So let me give the tab. That's it. So I would like this. See why we are using while true. So the code doesn't exit after 1 cycle. So it keeps running and creates a continuous loop for controlling the LED. I mean, allowing it to blink on and off indefinitely until the program is stopped. So the setup is the same, right? Then we simply alternate between GPIO high and GPIO low for every second. So inside an infinite loop. This is nothing but while of true is infinite loop. So if you have ever used an Arduino board, this example is the same as the blink LED example you can find with Arduino. So now this program works, but there is a small issue we need to fix. What is the issue? See, when you run the program, you can see that it doesn't exit by itself because of the infinite loop. Let me run this. You can see here. In the output, you can see, right? It will turn on, turn off, turn on and turn off. See, if I stop this, it will stop, but you will find there is some issue. So, you have to stop or you have to kill the program by yourself. Either by clicking on the stop button on Tony ID, or like you can also stop this by pressing Ctrl+C in the shell panel. Okay, I'm going to run this again. See, you will get error here. If I press Ctrl+C in the sense, you will get like keyboard interrupt, something like that. So when you kill the program, the line GPIO.cleanup won't have the chance to be executed. So the GPIO 17 won't be reset and cleaned up. So if you start the program again after killing it, it still works well. And there is no risk for your Raspberry Pi because you are using the GPIO for the same purpose, but you will get this warning like this. It will ask you to use GPIO.set warning of you have to pass false to disable this warning before this line. I mean, in between this line. It will ask you to do that. So, as suggested here, you could use GPIO.set warnings of false at the beginning of your program. So, you don't have the warning again, but that's not a real solution to this problem. So, how to overcome this? So, we are going to use another method. Make sure the LED GPIO is cleaned up every time or not. So, to be sure that the LED GPIO and all other GPIOs is cleaned up every time we kill the Python program, we need to use one structure called try or catch structure to be able to catch the Ctrl+C. So we can do an action just before the program exists. So here what I'm going to do is that I'm going to put this while true block inside the try block. I mean try structure. Okay, nothing. Here I am going to add try structure here and I am going to put just, we need to press the indentation here. So here I put the while true block inside the try structure And I'm going to add one more thing like except what we got an error like keyboard interrupt, right? So we need to give this keyboard interrupt. It will turn to, no, I'm giving wrong spelling. So it will turn to the different color. We need to put this GPIO.cleanup inside this. Okay. So see, I'm putting while true block inside the try structure and I put GPIO.cleanup inside the except keyboard interrupt. So here we have not changed anything in the setup and the main functionality stays the same. What we have done is that we just put the infinite loop inside a try or catch in Python 3 structure. So here what will happen when you run this program? First, the LED GPIO will be set up. Then we enter the while loop and make the LED blink because the while loop is inside a try block. Then when we press Ctrl plus C, we will be able to catch the corresponding exception like keyboard interrupt. So we add an except keyboard interrupt to execute some code when the exception has been caught. So in this except block, we use GPIO.cleanup. So after that, the program continues its execution after the try catch. So in this case, because there is nothing more, the program just exits. So note that if you are using the Tony Python IDE, to kill the program, you will have to select the shell panel and press Ctrl plus C. If you stop the program with the red stop button here, the keyboard interrupt won't be triggered and your GPIO won't be cleaned up. So now let's run this and see. I'm going to run this. See here in the output, you can get high and low. For 1 second it will be high and 1 second it will be low. It will continuously blink like that. In the shell panel, I'm going to click Ctrl plus C. So see the output, the LED stop blinking. If I run this again, it will start blinking. In the shell, I'm going to press Ctrl plus C and I stop the program. This is how you should start and stop your program. Okay, then you will able to use this GPIO.cleanup method. Okay, so this is how you make your LED blink. Now we are going to the next part, which is we are going to add push button to our circuit. Okay. So this is the right time to switch your masterclass into 1 month internship. So in this 1 month internship, what you will have? So 90 days access to complete records of the sessions. You will get 30 days of completing that masterclass. So you will get your internship. You can download all the presentations. You will get 8 plus project source code. And for 4 weeks, you will have Zoom class. So you can clear your doubts or queries with your mentor. And that is a separate group for internship members. You can communicate with your coordinator. And you will get access to Pantech community, and as well as there will be a career guidance session. So the actual amount of this 1 month internship is 1,999, but there is a discount amount is available for you, which is only for 699. And use this payment link to make your payment, and please make use of this chance to get your 1 month internship on Raspberry Pi. And also you will get these 8 projects in this internship, which are smart surveillance system, number plate recognition, eye blink based wheelchair, smart parking system, smart voting system, fire detection using OpenCV, drowsiness detection and driver monitoring, face mask detection based on attendance system. And there will be a bundle course which is available for you. In the lineup, you will have IoT, Python and Raspberry Pi. So what you will get in this bundle course? Self-paced 90 records, and there will be a live sessions, and you will get certificate, and there will be a 20 plus projects, and you will get 1 year validity. You can download all the presentations. You will get internship confirmation letter, and also there will be a hackathon session. So the actual amount of this bundle course is 2,999. So there will be a discount amount for you, which is only for 1199. So this is the payment link. Make payment using this link. So we are going to add push button to our circuit. So the LED connection is same. We just going to add one more push button here. Okay. So let us finish the connection first, and then we can go for the programming part. Okay. So for the push button, I'm going to take the pin number. I mean GPIO pin number 26. So here 26 from the left side, you can find it out 26. We need to connect. So how to make a connection? See, here we place the push button like this. So one end of the push button, we need to give power. We can give 3.3 volt. So here I am going to connect the 3.3 volt to the Raspberry Pi 3.3 volt. 3.3 volt of Raspberry Pi is here. We need to connect this pin to this pin. On the other end of the push button, you have to place one 10k ohm resistor. We have already talked about this. Yes, we have already discussed about this, because the internal pull up or pull down resistor is only about 50k ohm, right? So we have to place a strong resistor than that. So I'm going to place 10k ohm resistor. I'm going to place it like this. One end with the push button and another end of the resistor, we need to connect it with the ground. Okay, so the ground of you can find it out. There are 8 grounds. You can connect with any ground you want. And the other end of the resistor, here in the picture it shows 2 resistor, that you can go for single resistor, or if you want you can go for 2 resistor. Okay, so you have to place the pin number, I mean the pin number 26, you have to connect here. Now another end with the same leg you have connected the resistor. You have to place the same end of the push button. This is how you connect the push button. So let's go for the connection now. So here I am having my push button. I am going to connect it like this. I am going to place resistor. Let's make the connection. So this end I am going to connect it with 3.3 volt. Okay, and give the red pin. Okay, so here I am going to place 3.3 volt, and here we need to connect it with ground. So first let's connect the ground. So in the picture itself you can see I am going to connect it with the right side third pin. Okay, so I mean here ground, and this is the power pin. I am going to connect it with 3.3 volt. So now we need to connect the GPIO pin, the same end of the resistor 26, right? This is our connection. Now let's move to the programming part. Let me open our Raspberry Pi. So here let me erase this. No, we don't have to erase this, just few lines. Okay, so let me command this. Okay, everything is same. We need to import rpi.gpio as GPIO. We need to use import time, and later we can come to this LED pin. Now let's write program only for button. Okay, so okay, let us erase this and as well as this. We just keep this one. Okay, so here we need to mention our button pin. So I'm going to create a variable called button pin. I'm going to give pin number 26. I mean GPIO 26. So these are all the same. So let me command this line also. Okay, so here GPIO dot setup, inside we need to mention button pin GPIO dot. I'm going to take this as input, right? So after this I'm going to create while true. Inside I'm just going to print the button state. So print inside GPIO dot input as a parameter inside we need to pass our button pin. Now I'm going to use time dot sleep. I'm just going to give 1 second, and after this I'm going to use GPIO dot cleanup. Okay, so this is our program. We just want to print the button state. Okay, so now I'm going to run this. See, now the button is not pressed. That's why we are getting 0. If I press the button, see, now our output is 1. If I remove my finger, you will get 0. If I press the button, you will get 1. Okay. So now let's move to the next program. I'm going to stop this for now. Okay. So now we are going to power on LED when the button is pressed. So we are going to power on and power off the LED using pressing the button. Okay. So the connection is same, but we are going to turn on and turn off the LED using push button. So for that, let's write the program here. Same thing. Let me uncommand this LED pin and let me uncommand this setup line also. We need this, right? So inside this, we are going to make a condition. What condition? Let me erase this. Here, I'm going to use, and also we can go for that try structure. Okay. Okay. So try. I'm going to give it like this. And inside this, I'm going to make a condition. If GPIO dot input of, we need to mention that button pin, right? So button pin, which is equal to GPIO dot high. We need to mention that colon. Don't forget to add the colon at the end. So if this condition is true, inside I want to make my LED high using what? GPIO dot output. Inside we need to pass LED pin and GPIO dot I want to make my LED high. Here I am going to create else. So if button is pressed, if we press only, it will be high, right? So if the button is pressed, I want to make my LED high. If button is not pressed, I want to make my LED low. So here what we need to give? LED pin, comma, GPIO dot LOW, low. That's it. And here we can put GPIO cleanup into except keyboard interrupt. Okay. Okay. Let us put inside, sorry. We just need to make a indentation here. That's it. Okay, let's see what will be the output. I'm going to run this. Now the LED is turned off because I didn't press the push button. I'm going to press it. Here you can see the LED has turned on. Now it is turned off. On, off, on, off. So this is our output. Now I am going to stop this using what? In the shell, I am going to press Ctrl plus C. Without any error, without any warning, I am just stopped my program. If I press this, you won't get anything. If I run this, it will turn on and turn off. I'm going to stop this program. So in the shell, I'm going to press Ctrl plus C. If I press this, you can see nothing is happened. So this is our output. Okay, so now this is the right time to switch your masterclass into 1 month internship. So in this 1 month internship, what you will have? So 90 days access to complete records of the sessions. You will get 30 days of completing that masterclass. So you will get your internship. You can download all the presentations. You will get 8+ project source code. And for 4 weeks, you will have Zoom class So you can clear your doubts or queries with your mentor. And there is a separate group for internship members. You can communicate with your coordinator and you will get access to Pantech community, and as well as there will be a career guidance session. So the actual amount of this 1 month internship is 1,999, but there is a discount amount is available for you, which is only for 699. And use this payment link to make your payment, and please make use of this chance to get your 1 month internship on Raspberry Pi. And also you will get these 8 projects in this internship, which are smart surveillance system, number plate recognition, eye blink based wheelchair, smart parking system, smart voting system, fire detection using OpenCV, drowsiness detection and driver monitoring, face mask detection based on attendance system, and there will be a bundle course which is available for you. In the lineup, you will have IoT, Python and Raspberry Pi. So what you will get in this bundle course? Self-paced 90 records, and there will be a live sessions, and you will get certificate, and there will be a 20 plus projects, and you will get 1 year validity. You can download all the presentations. You will get internship confirmation letter, and also there will be a hackathon session. So the actual amount of this bundle course is 2,999. So there will be a discount amount for you, which is only for 1,199. So this is the payment link. Make payment using this link.